Okay, I'm going to let's wait till we get our last student adding in. There might be a few more that show up. So you guys are welcome to chime in at any time. What I had a couple students contact me that it would be helpful to actually make videos on of the review test, and I actually looking at the actual test and the review test. I agree that probably the best use of our time is to work through each of the review questions. And so what I plan on doing today is, unless there's some other questions, is to just start going in and working through the first three sections that we had listed, that we actually have a practice quiz on this. And then that way I could, I think in this hour, we can work through most of these questions. And since I'm recording this, and that would be something you all could look back on. And then if we run into any questions as we go through these, you can chime in, and so then I can explain them. I think that'll maybe even make a little bit better explanation on them. If we don't get all the way through it, then what I can do is I can finish whatever we didn't get done during class time a little bit later, or we'll go a little bit. We'll just see how far we get. Does that sound reasonable?
Yep.
Okay, sounds like a good idea. Okay, so we'll do this, and then on Friday we'll do the second three that was sort of I've got down for today. And let's see. Okay. Let's see if it's hard. Sometimes I don't see the chat at the same time when I share the screen. Here we go. Yes, okay, perfect. So we'll work through these. We're going to look at the indefinite integrals for this part. What you need, there's three integrations you need to know how to do. One is a polynomial where you just add 1 to the exponent and divide by that new exponent. The other is you have to integrate e to the x is e to the x. And then the last one, if we have 1 over x, that's natural log of x. This last one also could be written as x to the minus 1 dx. You get the same thing. Okay, so but those are basically the three you do. And then when we look at A, we've got 4 different terms. We integrate them each separately. So the first one is going to be 2x to the 4 plus 1 over 4 plus 1, which is 5. This gives us a minus 4 x to the minus 2 plus 1, which is going to be minus 1, right? This one here, we're going to get plus 5x to the minus 5 plus 1, which will be minus 4. I guess there's this last one, 3 integrates as 3x, right? Think of this as x to the 0, so you add 1 to that, and the last part will just integrate to 3x. We get a constant, and then we just finish up by, this is 2/5 x to the 5th. This is a negative and negative, so that makes it a positive.
Professor, quick question.
Sure.
In regards to our quiz and in regards to the exam, if we just had what you had above, would that be sufficient, or would we have to simplify it?
Say that again.
In regards to the quiz and the exam, for instance, what you had above right there, would that be sufficient if that was our answer, or would we have to simplify?
If it's multiple choice, you'd have to be able to recognize the correct answer.
Okay.
So yeah, if you put on the multiple choice part, and then yeah, for the ones that are essay, you would want to, finalize everything. You wouldn't want to just leave it as x to the 4 plus 1. You'd want to write as x to the 5.
Yeah, I know. Obviously, if we had like 2x 5 over 5, would that be okay?
Oops, this should be over 5. 2 over 5.
Okay.
Yeah, so can be multiple ways. Again, on the multiple choice part, that should be pretty straightforward because you just have to choose the right answer. But on the essay part, they can be written in different forms, yes. And since it's going to be handwritten, like a WebAssign is critical about whether you put a plus C, whether it's a big C or little c, I'm not going to care. Okay, so the essay ones, you'll just write them out. The multiple choice ones, you'll just choose one of the choices, and they don't get too fancy on you. You'll be able to see the right ones from the wrong ones. Okay, so far so good. Any errors that I made there? Okay, we'll move on to the next one. And again, I'll post both this as a solutions guide as a Word document, or I'll turn it to PDF. It's usually easier to go that way. And then I'll also have the video posted. Okay. So for this one, for B, this part, remember, this is 1 over x. So that's going to integrate to the natural log of x. And we've got 7 times it, so it'll be 7 natural log of x. They put the absolute values there.
You also write it as 7x negative 1.
You could, and then it would integrate to natural log of x. So yes, you could think of it as, and this also integrates to 7 natural log of x. Okay. Too messy. Okay. So absolute value of x. So that gives you that answer. And this one, what you would think is in the interim, rewrite it as 1/3 x to the minus 7th. So again, we'll add 1 to the exponent. So add 1 to -7, you get -6. You divide by the new exponent, so that's going to be a -6. So our final answer, 7 natural log of x, 3 times 6, so we're going to get a -1/18 x to the -6 plus a constant. And again, where I'm taking this from is the resources for final exam. It's just the exam 3, it's listed as exam 3 review. They do have the answers in there, but so I'm just hoping that by going through this helps you think your way through the process as well. And any ones you struggle with a little bit, look for some similar type problems, because the test will have similar but different problems. Okay. So for this one, let's go ahead and rewrite it first. That might be a good process. So this will be 2x to the -2, right? So that we bring that up. We'll rewrite this one as -5. This square root is x to the 1/2 power, or 0.5, however you want to do it. Okay, and again, we use the rule where we add 1 to the exponent. So this is going to become 2. -2 plus 1 is -1, and over the new exponent, which would be -1. Give myself a little more room. This one, we'll have the negative coming down, 5. Add 1 to this exponent, or 2 over 2, right? 2 over 2, so you're going to have 3/2 as your new exponent. So we divide by that new exponent. And this might be the one that's a little challenging on simplifying. When you're dividing by a fraction, you flip and multiply. So we're going to multiply by 2/3. So it'll become 5 times 2/3, which gives us 10/3 as our coefficient. So we get -2 x to the -1 minus 10/3 x to the 3/2. And then just know that if it's a multiple choice, this x to the -1 might be written as -2 over x. So just be able to recognize the different styles as you choose your multiple choice.
C.
What's that? Oh,
I forgot plus C.
Thank you. And again, on the multiple choice, that'll be there. So we're not going to get you there, but thank you. That's why I need you here. All right. And do slow me down. Might scare me a little bit, but that's okay. Anytime you want to stop, we got to go. So this one integrating, again, each, we've got two terms. So this first one just integrates into e to the x. This one, again, we're going to add 1 to that exponent and then divide by that new exponent. So it's minus -0.3 plus 1 will be positive 0.7. And then we're going to divide by 0.7 plus a constant. I'll try to keep on top of that. Now, we could leave it like this, but I want you to, again, a multiple choice, what they may say, well, this is 0.7, which is 7/10. So just like last time, you flip and multiply. So you may see this one as a multiple choice answer as 7/10 x to the 0.7 plus a constant. Okay, so that's what happened, is that 0.7 is really 7/10. Flip it and then multiply, and that's so otherwise you might not recognize it. Okay, so far so good. Good. This one it might confuse you. You might think, well, they've got to do the product rule or something. What we're going to do is we'll FOIL this out first to turn it into a trinomial. So we're going to integrate. This gives us x squared. And then we get minus 2x and a plus 3x. So that's just a plus 1x. And then the last number is 3 times 2 is 6. So we get a minus 6 dx. Okay. And then we just integrate term by term. So x squared, we add 1 to it. So that's going to be x to the 3rd divided by 3. This is x to the 1st. So that becomes x squared, again, divided by 2. And the last one just becomes minus 6x plus a constant. So far, so good? All right. And remember, I can't really see the chat when I'm this way. So just unmute yourself and holler if I do something wrong. So this one, what we want to do first is we want to divide each of these by x so that we have it 3 different terms. Okay, so this is not a U substitution. So x squared divided by x is x. 5x divided by x is 5, and negative 2 divided by x is negative 2 over x. If you want to write this as x to the minus 1, you could do that as well. So we have x to the 1 plus 5 minus 2x to the minus 1. The one thing I don't like writing minus 1, I like leaving it like this. It reminds me, I see a natural log here. Here you might be tempted to add 1, but hopefully when you add 1, you see you get x to the 0, which is 1, and it disappears. So you just have to remember that this part, x to the minus 1, is going to integrate to natural log. So again, term by term, x to the 1st, we add 1 to the exponent, so that gives us x squared over 2. When we have a constant, that integrates just as 5x. And then x to the minus 1 is going to integrate as natural log of x.
Why did it become x squared over 2 from x1?
You add 1 to the exponent.
Oh, and then you put it under the denominator.
Yeah, and then divide by that new exponent.
Yeah, I took my eyes off for literally 3 seconds. My bad.
I know it's hard. It's hopefully we don't do that when we're. So I hate when that happens and I'm driving along and I go, oh dang, you know, you gotta, yeah. Distracted driving is not good. Distractive math's okay because we can recover from that. Nobody's died of distracted math yet that I know of. Okay, so far good?
Yeah.
Awesome, awesome. But it just, yeah, that's why we need it, because sometimes I might miss explaining something, and then all of a sudden it's a lot harder. Now these next ones, what's going to happen is it's really, we're doing the same thing, except they're giving us enough information, I put the plus C, that we won't have to put the plus C. Okay, so we'll go through these 3, and let's see, what are we doing on time? We're doing pretty good, 15 minutes so far. Okay, so what it's asking is find f of x, and notice that this is the derivative, so really it's asking us to find the antiderivative of 9e to the x plus 9, and it's giving us a point that when x is 0, y is -1, so 0, -1's on this graph. So what we're going to do is we're going to first integrate, and then we'll use this information to figure out what c is. Okay, so to integrate this, 9e, okay, integrate this, the first part is real simple. I should put the dx, right? It's 9e to the x. It's just itself. The second part is just going to be plus 9x plus some constant, and this is the function value, right? So we've integrated it. This is now f of x. So what we know is when we plug in 0 for x, the output will be -1. So that says that the output is -1 when we plug in 0 for x. So we get 9e to the 0 plus 9 times 0 plus some constant. And so now we do the math. So we get -1, 9e to the 0 is 1. So 1 times 9 is 9. 9 times 0 is 0. So then we get plus our constant. We want to solve for what that constant is, so we subtract 9 from both sides. And we get that the constant, oops, you see what I did? I already did the math on the way. If we're subtracting 9, we will get -10. Oops. So subtracting 9, we get -10. So then our final answer is that f of x is the function 9e to the x plus 9x minus 10. Okay, does that make sense? Doing okay?
Yes.
Okay, thank you. And again, these videos will be posted afterwards, but so I'm going to keep trying to move through, but slow me down anytime. Same type of deal. We've got the velocity of a particle moving as this, and we want to find the position function. So we remember that when we integrate velocity, we get the position function. So that s of t is going to be equal to the integral of t squared plus 6 dt. And then we've got this point here, s of 3 equals 0. So when we plug in 3 for t, we get 0. So we'll integrate first. T squared integrates into t to the 3rd over 3. So we added 1 to the exponent, divide by the new exponent. 6 integrates into 6t. And then we've got plus a constant. When we plug in 3 for t, the answer is going to be 0. Okay, so the output is 0 when we plug in 3. So 3 to the third over 3 plus 6 times 3 plus a constant. So we get 0. This is going to be 27 over 3, which will be 9. So, or you could think it's really 3 squared, however you want to do it. This is 3 times 6, which is 18, plus a constant. So 9 plus 18, we're back to 27. So we subtract 27 from both sides. And so our constant, get a little bit higher here, our constant is going to be negative 27. So our final answer would be the function here, that s of t is t to the third over 3 plus 6t minus 27. Okay, so it's just like the last one's, integrate, but we've given enough information to find the constant. Let me just, so let's take that one out. That back to where it's supposed to be. There we go. Okay. Almost through the first section. We're doing pretty good. And again, this one's the same thing. We're dealing with a derivative. We want to find the, this is, and again, a marginal cost. So we want to find the original cost function. We will integrate it, and then we're given that the cost to produce the first unit is $5. So what it's saying is that C, since X is the units, C of 1 equals 5. Okay, so we use that to find the constant. So we're integrating 0.5x plus 1 over x dx. This one is x to the first, so we get 0.5 x squared. We're adding 1 to the exponent and then dividing by the new exponent. 1 over x integrates as natural log of x plus a constant. So let's clean this up. This is 0.5 over 2. 0.5 is the same thing as 1/2. So you could write this as 1/4 x squared plus the natural log of x plus a constant. And what we'll do is we'll plug in 1. This is what our original cost function is. So when we plug in 1 for x, our answer is going to be 5. So what we get is 5 equals 1/4 times 1 squared plus the natural log of 1. We don't really need absolute value because it's positive, plus a constant. 1 squared is 1, so this is 5 is equal to 1/4. Natural log of 1 is that 0? I should know this, right? Let's turn it sideways. Let's just plug it in. We can, where's my natural log? Natural log 1, natural log 0. Yeah, natural log of 1 is 0. That's where it crosses the x-axis. Yep, that's what I thought. Thought they'd make it easy on us. So this part is 0. I'll just put that there. So then we're left with 1/4 plus a constant. Subtract 1/4 from both sides. So we get, let me come over here, that our constant 5 minus 1/4, if they're going to write it as a fraction, right, we need a common denominator. 5 becomes 20/4, common denominator, right? Multiply by 4/4. So you'll get 19/4 is what our constant equals. So up here, we just replace that. We get 1/4 x squared plus the natural log of x. So did we get that right? Yeah, plus 19/4. So that's the original cost function, not the marginal.
On the test, always going to be a fraction, or can it be sometimes be a decimal?
It could be a decimal, so they could have it as 0.25, and this would be
4.75.
yeah. So it could be, but I just, and if it's not, if the multiple choice they give you fractions, you could turn those fractions into decimals. You just have to be able to match them up.
Yeah.
If it's on the essay, I'm the one who grades that, so I would accept either decimals or fractions.
All right, thank you.
Yeah, good question. Excellent. Okay, so now we're into integration by substitution. So if you remember here, we choose a part, and usually it's the part either in the parentheses, that's what we make u, or the part that's in an exponent. Okay, so what we do is we make a u substitution, and then we find out, we take the derivative of that. So over here, for the first one, we're going to make negative 3x. We're going to let u be equal to negative 3x. Okay, because that's the exponent part. What we do is we take the derivative of both sides. So we're going to find that du, derivative of this side, is just negative 3, right? Dx, and then we solve for dx. So we divide both sides by negative 3. So I'm going to write it as negative 1/3 du is equal to dx. So what the substitution is, dx becomes negative 1/3 du. This exponent becomes u. So we're going to rewrite this. I'm going to put this negative 1/3 in front of the integral. Could do the same thing with the 16, but I'll just wait a moment. E to the u du. So notice I made dx, there's the negative 1/3, and there's the du. And now I just need to integrate e to the u, which is e to the u. 16 is a constant multiplier, so is 1/3, so I end up with negative 16/3 plus a constant. And then the last thing I need to remember to do that back up there, is to back substitute for u. So u is actually negative 3x, so I just have to rewrite this as, there we go, negative 16/3 e to the minus 3x plus a constant. Now, after you've done this a few times, you might have seen, yeah, you just, when you integrate this, you just divide by negative 3, and that's really all that happened. The 16 came along, we divided by negative 3. Okay, so they've got some rules, there's sheet of them where you could kind of memorize these if you wanted to. Okay, so far so good? Okay. So what do we want to make the u here? What should u equal?
Why
How
don't we
about-
put the equation in the parentheses?
Exactly. So just make the whole parentheses part the u. So we get 5x minus 2. Take the derivative of both sides. So du, derivative of this first part is 5. Derivative of negative 2 is 0. So it's just 5 dx. We divide both sides by 5. So we get dx equals 1/5 du. Make the substitutions. This becomes u. Dx becomes 1/5 du. So just like before, I put the 1/5 out front just so I don't have to deal with it. So notice the du has really two parts. Oh, u goes inside, but it's still to the third power. So what is u to the third? Add 1 to the exponent. So it becomes 4. Divide by that new exponent. And then we have the 1/5 constant multiplier out front. We add a constant. And then we're going to back substitute what u actually is, which is up here. So we're going to clean this up. 5 times 4 is 20. So I'm going to write it out as 1/20th. U is 5x minus 2 to the 4th plus a constant. And that would be our final answer there. All right. This one we're going to need to rewrite. Well, we don't have to, but it might be helpful. So we'll do the integral 2x minus 5 to the minus 1 power. And so does this help? What should we make our u? Again, the thing inside the parentheses. So we let u equal 2x minus 5. Take the derivative of both sides. So over here, this derivative becomes 2. That's 0, so it's 2 dx. Divide both sides by 2. So dx is 1/2 du. Now let's make those substitutions. So this becomes u to the minus 1. Dx becomes du with a constant multiplier out front. U to the minus 1 integrates as what? Anybody? All fall asleep? No.
Let me type it.
Natural log,
Yeah.
of u. Good, good. So just remember that's the one that we tend, we can't, if you start adding 1 and you get 0 for your exponent, that hopefully will remind you, oh, that's got to be the one, that's the natural log. And then again, we back substitute, so we get 1/2 natural log 2x minus 5 plus the constant. And again, you could have, if you wanted to, you could have just put this as 1 over u, but either trick, either make it to the -1 or work it that way. And we're going to start getting to the ones that are a little more complicated. And these ones definitely, these sort of come from the chain rule. Actually, all of these are chain rule things. So you see this 4x in the front is sort of like a derivative from the chain rule of what's up here. So when we have an exponential, we let the exponent part be our u. And then we take the derivative of both sides. So we get du. Derivative this time is going to be 2x dx. Again, derivative of -3 is 0. We've got to get dx by itself, so we divide by 2x. So when we go and substitute for dx, it becomes 1 over 2x du. So now we're ready to make our substitutions. And what I do is this front part, 1 over 2x, I'm going to make it a fraction with this 4x. So it becomes 4x over 2x e to the u du. So notice how dx got replaced by these two parts. This simplifies. This becomes, the x's cancel. 4 divided by 2 is 2. Okay, so I'm going to make this 2 the integral e to the u du.
Alphatrons.
And
I'm okay with that, yeah.
And e to the u integrates as e to the u. So it's 2 e to the u plus a constant. And then the last thing we need to do is back substitute. What was u? It's x squared minus 3. So it's 2e x squared minus 3 plus a constant. So that's that one. And again, you could take the derivative of this and we should get back up to here. That's how all of these work, but I'll leave those for you. So we'll try to keep going through. It's 11:20. We'll definitely get through 2 of these. We'll get through the rest of these. I might just, integration by parts may take a little while, so I may just continue that video after a little bit of a break, if that's okay with you all. But it'll all be there, okay? So this
Hello?
one, yes,
Oh, sorry, never mind.
that's okay. Yeah, do you have a
Hello?
question, Jacob?
No, I don't know why. How do you? I'm trying to turn off my microphone.
Oh, I'm muting you because so there should be a mute, but I'll mute you. There, you're muted now. And so we'll continue with this one. And again, as we look at here, whatever's in the parentheses, that's what we want to make our u. We take the derivative, so that du, this becomes 2x dx, and derivative 1 is 0. Get dx by itself. So dx will be 1 over 2x du. And then we go make the substitution. So this becomes u to the 10th power. Dx becomes du, and this 1 over 2x comes out front. So we have x over 2x. The x's cancel, so this becomes 1/2 u to the 10 du. When we integrate u to the 10, we add 1 to the exponent, so that becomes u to the 11th, divided by that new exponent, and we still have this 1/2 out front, plus a constant. And the last step is to back substitute for u. So u is actually x squared plus 1. We'll take 2 times 11, so that gives us 1 over 22 x squared plus 1 to the 11th power plus a constant. Okay, so far so good. Doing all right. Excellent. Okay, 2 more for 13.2. So again, this one we see is going to be an x, this is inside a square root, so that's what we want to make the u. Take the derivative. Let me give myself some more room here. So du, in this case, is the 2 comes down, so we get a minus 2x dx. Divide both sides by minus 2x. So we get dx 1 over negative 1 over 2x du. Make our substitutions. So we have 15x over 2x, and don't forget this little negative. We put it out front here. This becomes a square root, which a square root of u. I'm going to rewrite that as u to the 1/2, and then the dx becomes du. Okay, so we've made all the substitutions. We add 1 to this exponent, and again, when you're adding 1 to an exponent like 1/2, what we want to do is add 2 over 2. So this integrates u to the 3/2 divided by that new exponent. The x's cancel, so we're left with 15 halves, and the minus comes down. And since the 3/2 is in the denominator, we flip it and multiply. So I'm just going to, over on my scratch paper, I'm going to have minus 15 halves times 2 over 3. So the 2 cancels with the 2. The 3 cancels with the 15, leaving a 5. Myself a little room here. So all of this becomes just minus 5 u to the 3/2. I guess we should always put plus a constant. And then in the last step, as I back substitute for u, it's going to be minus 5 minus x squared plus 7 to the 3/2 power, plus a constant. Okay, is that one okay? Questions? No. Okay, let's move on. And if it's okay with you, let me do this last one, and then let me have a little bit of break, and I'll do a whole separate video on integration by parts. Okay, so this one, again, we want to make it the u, the inside of a parentheses. We have 2 parentheses though, so it's going to be the one with the more power. So this one's to the 9th power. Let's make everything inside here, we'll call that our u. And what you'll see is, because this is x to the 3rd, there's an x squared, it looks like this front one is the derivative of the inside, and that's because of the chain rule. So it'll all work out x to the 3rd plus x minus 2. That's what we want to call u. So du, take the derivative of both sides. This is going to, the 3 comes down, x squared. Derivative of x is 1. Derivative of negative 2 is 0, so dx. Divide both sides by 3x squared plus 1, because actually it's got a parentheses around it. So dx is 1 over 3x squared plus 1 du. And so we can see that when we're going to integrate this, we make our substitution. So this 3x plus 1 just comes down. This 1 over 3x squared plus 1 is what goes in the denominator here. And you see they gave us a nice one. It's all going to cancel. This part here becomes u to the 9th power, and the dx becomes du. Okay, so we made these both, dx became actually both of these. So this front part's going to cancel, and that's just 1. So it really is just the integral u to the 9th du. Add 1 to the exponent, we get u to the 10th. Divide by that new exponent plus a constant, and then we just back substitute. Okay, so I'm going to write this as 1/10 times what u is, which is x to the 3rd plus x minus 2 all to the 10th power plus a constant. And again, if you wanted to, you could take this derivative, the 10 would come down, that cancels, and then you get this part to the 9th times the derivative of the inside, which we've already done. But again, that's that. Okay, now we've got the whole section 4.1, but I'll be able to do that video separately, because that's at least, that might be an hour in itself. It might only be 30 minutes, but probably a little bit longer than we all want to stay. So are there any other questions we can finalize with that, either about the exam or what we're doing? No questions. Okay. Do you think this was a useful way of our
Thank you,
time?
Professor.
You're welcome. Okay, so Friday we'll pick up with the next 3 sections, and then over the weekend I'll do a video on the remaining 3, so that we'll have a review. We'll have videos on reviewing each of the questions on the review. Awesome. So take care, and we'll be in touch. Email me if you have anything special. Okay.
Thank you.
Thank you.
Have a good day.
You too.